Hello everyone. Welcome back. And today we are going to talk about the collision system in games. Actually, I'm going to divide this video into two different sections. One is like the physical collision, and another one is the tracing techniques. Without understanding the collision, there is no purpose in learning the tracing. Okay, so let's get started. So first of all, what is meant by collision? So let's imagine there is a two different object in the game world. For example, there might be an weapon that gets spawned in front of the player, and you need to you need to attach the weapon to your body. Okay, so for those things you need to somehow interact with the weapon. For those things we have a lot of the different actors in the game. Like I said, in Unreal Engine we need to call everything as an actor, right? So there might be building, there might be some other object, there might be enemies, a lot of the different things that will be in the game. For defining them, we need to have separated the things like those are visual kind of stuff, and these things are used for physics things. So collision will help you to make do the physics things, and it can help you to overlap, and it can be used as trigger point to do something. We will talk a lot of the things about that in the Unreal. But before that, we need to also understand a key point like collisions are not always visible. So they will be invisible. So that is for the optimization, and as well as there is no need to explicitly show them in the games. That is the meaningful things. Okay, so let's say if I need to open a door. Okay, imagine I need to open if we go for your shopping malls, there will be the automatically open door based on the sensor. So you don't need to just highlight the sensor area like please stand here, this is the range of the sensor. No, if you're just actually getting closer to the door, it will automatically get opened. So the same concept gets applied here in the games as well. So there is two types of collision that we can able to see in the common pattern in the game development. The first one is axis aligned bounding box, and second one is oriented bounding box. So axis aligned bounding box, Unreal uses this most. And what is the core concept of this is, um, you can imagine a rectangular box that stays aligned with the world axis. So since we already know what is meant by the local space and the world space, right? So in the world axis x, y, z, imagine there is a rectangular box. So with the particular rectangular box, you can able to calculate the collision between the instigator and the object that owns the collision material. Okay, so it is faster to compute as well, but not precise when rotated. So you can imagine this in the kind of 2D manner. So let's say I have the box here, right? So there might be some other box that can be placed next to this one, and you can imagine they both are colliding each other. Okay, so this is well perfected for the 2D as well, and in Unreal this concept is used in the 3D as well. So that is purely dependent upon the world axis. So like I said, it is very faster and easy to compute, but not precise when rotated. So for that kind of purpose, we need to have the second kind of collision that is called the oriented bounding box. So oriented bounding box, it's also very simple. Like imagine you have attached a box component or a sphere component to the actor, and when the object rotates, the box also itself need to recalculate its things. So in generally you can say that, okay, if you need to rotate an actor, you can just use the set actor rotation. That is very easy. Yeah, but in theory, mathematically, when you start rotating the object, the things will get complicated. But you can get the accurate collision result, and it can be much more performance demanding one. And lot of the physics things, this oriented bounding box will be used. And third thing is sphere, capsule, convex hulls. So those things are very common. so that will define a shape, and based on the above two, those things are just an additional things. Okay, so now let's talk about the next one in Unreal. So in Unreal, basically we need to understand that um, all the collision kind of stuff are completely separated. For example, you can add a primitive component, which is the core component for making the collision system. And from the primitive component, we have derived a box component, which gives you the shape like a box that you can attach to the actor. And then we have the static mesh component. So static mesh component, it is mean like somewhat you have defined a model. You can imagine like define a model using the DCC tools. So and you are starting to import that particular model into the engine. Then somehow maybe at sometimes there is a collision that can be that comes attached with the particular object. So that is a one kind of method that people will use this for making the collision. But to be honest, in the real-time scenarios, lot of the games, including the AAA ones, they don't use the very complex collision things. Example, you might think like you can see like, okay, this object is a complex one. Okay, the character, how could I define the character? So we all know, since we have following the tutorial, right? So we all know that the character collision is simply a capsule one. Okay, capsule component is dealing all the collision related stuff. It is also handling the physics kind of things. To do a physics kind of things, you definitely need to have a collision component within your actor. So commonly in Unreal, we have the box component, sphere component, and most probably those three we will use. And even if you have the complex object, try to use a simple collision for them. That is the best way to define them. I will open the Unreal Engine and I will start a small demonstration here. So I have opened my engine. Now we're gonna see here. I'm going to create an actor. Okay. So creating a blueprint, go for the actor. Just name it as the colliding actor. So just name it as the colliding actor, and I am just opening those up. And you can see there is nothing. We already know if I drag and drop this into the world, nothing will be there. So for making these things, I'm going to add a component, and like I shown on the slide, it will be like the box collision, or it will be like the sphere collision, or it will be like the capsule collision. Those three things we will mostly use. For the simplicity sake, I'm going to use the box collision for now. Okay, so box collision for now, and I might say the colliding area. So I might say the colliding area. So a lot of the people I'm seeing doing the common mistake, like they have added the cube and they start scaling the things. Actually, this is the default one, and started scaling things like this. No, this is not useful for this scenario. So you need to go for the shape in the details panel, select the box collision component, go for the details panel, and you can see here we have the shape, we have the box extent. If I just alter the things, it will do the same. Okay, our scale won't change, but this is a perfect optimized way, and this is the actual method. Okay, so box extent, talking about the box extent, like I said, this is actually talking about the AABB like we have seen in the slide, right? So this is the actual concept that we have seen in that type. So thanks to the Unreal, they have already implemented the stuff. We don't need to do the lot of underlying mathematics behind those things. So AABB axis aligned bounding box, this is the one, and I'm just selecting those up. Even if I just drag and drop this into the editor, you can see in the design time you can able to see, but if I start playing up, I can't able to see anything, right? So to make that visible, I need to select the component. This is common for all the components, so hidden in game by default. I'm going to uncheck it, so now it will be visible in the game. Okay, so currently you see the character is not responding to the box. It is like there's something that is empty here, right? So here comes the next concept, whether we need to define some things. Like in the collision channel, we need to define the collision properties. Okay, so I am selecting the colliding area, which is the box collision component, and I'm going for the details panel. Just scroll down, you can see the collision category, and below that we can able to see the some kind of options. It is like overlap all dynamic. So I'm going to change it for the custom for now. So I'm going to change it as custom for now. So we can able to see collision enabled object type. What are those things? So what are those stuff? So like I said, we have three different kinds of things that we need to consider. So first thing is object type. So object type defines like what kind of object is this. So this is for an representation. You don't need to get confused like is this a building 1, building 2, building 3. No, you need to collectively think like in an abstract manner. Example, we have enemies and character, right? We have enemies and we have a player character. So you might can say like player. The object type is player. So type is just like a preset that we can able to define. Okay, this kind of object in the world according to the collision system I have categorized in a way like this. So this is the good definition for the object type. And second thing is trace channel. So trace channel we will talk about in the next section. That is a different one. And third thing is responses. So you can able to understand yourself like responses means, right? If two object starts or trying to interact in the collision system, they can give this kind of result. One is they can block each other. Second thing is they can overlap each other. And third thing is they don't need to care about those things. The first two options are possible, but what about the third one? The third one is actually essential, and that is a must needed one in the games, because you don't need to always force the engine to check between the block and the overlap. Sometimes you need to ignore all other channels, so you can reduce the computational things and you can help the engine to keep the performance optimized. So as an best practice, so keep your gameplay specific channel separate from the physics things. So like I said here, ECC game trace channel, right? So this is like I said, we can deal this in the next section. For now, these three things I will show in the Unreal Engine how this has got implemented. So here you see the collision thing, we have the collision enabled. So collision enabled, actually this is called the very important part about how this particular box component is going to interact with the collision system. It means, does it need to participate in the collision system? No, collision means nothing. Query only means, okay, I can able to block an actor, but don't think like I can make the physics kind of thing. Okay, so that's only query only option. And third thing is physics only. Example, I don't give you any collision kind of thing, but I can react to the physics. Example, there is a blast that got happening in the game world. So based on the uh, blast radius, so the object can able to just fly around the things. Okay, based on the impulse, the object can able to fly around. So that is a kind of physical interaction that it can participate. And The third thing is collision enabled, which is query and the physics. So it will just give you, it will allow you for the query and it will also perform the physics as well. So please note here, this one is actually computationally expensive, but at the same time I'm not forcing you to just say like always use the query only. No, sometimes imagine there is a projectile kind of stuff, it needs both physics and the query, to be honest. Yeah, so like this we need to launch the projectile in a certain velocity, so this kind of action is purely based on the physics. And if the cannon blast, if the projectile needs to hit something and needs to query about the other actor and needs to get damaged itself, we also need the query kind of thing. So collision enabled is the best choice here. Okay, so these are the important things that we should need to consider when we start our collision thing with the particular actor in the Unreal. Alright, so for this example I'm going to say query only. Okay, and object type. So according to the Unreal Engine, for the collision system, what kind of object is this? Like I said, you need to think in a abstract manner. For this one, I'm going for the world dynamic. No, world static, that is enough. The meaning itself, the name itself defines the meaning. You can create your own object type as well. I will show that later. So for now, I'm going to select the world static, and this is the collision response. Like I said, ignore, overlap, block. So first I'm going to set everything to the ignore. Okay, so this object is now ignoring all the stuff. But for the player, so according to the player, I'm going for the third person character. So if I just go for the third person character, you can see we have the capsule component, right? So I'm just scrolling down for the to find the collision thing, and you can see the collision preset is pawn. Okay, but the object type, you can see it is a pawn. Okay, it is blocking all the things, it is blocking all the things. So for object type pawn, I need this actor to overlap. Yeah, you don't need to block it up, you need to overlap. Okay, so now character is actually saying like what kind of object. Here I see object type pawn. Okay, so colliding actor pawn. This actor, this blueprint, this actor is trying to overlap the pawn, but the third person character, this one tries to block the world static object. You can see here world static block. Okay, this object type is world static. So which one should happen now? Let's see. Clearly we can able to see the overlap wins, because both objects should need to say I need to block it, and this guy also I need to block the world static, which is the object type of this particular blueprint. And for the third person character it is blocking, and for the colliding actor as well it is going to block. They both are now blocking each other. Now you can see I can't able to go inside the sphere because they are blocking each other. So this is the important step that we should need to know in the collision system of the Unreal. So I can say overlap for now. Now if I give the overlap, I can able to get the events from this particular action. So scroll down again in the BP collider reactor, because that is causing the overlap, right? So you can see here on component begin overlap, on component end overlap. So on component begin overlap, on component end overlap. So two events are there. So if an actor is colliding, this event will get triggered. A small demonstration here. So here we can see who is just interacting with the object. So let's display this for the 5 seconds. Print string using the same one. Cool. So this means the actor is no longer inside me. Okay. As you can see in the top left, the name of the character which overlaps got printed. So these events are very helpful. Like in the game development, we will use them at lot of the different places. Lot of the different mechanics are already using this one. Okay, so this is the very core concept. And the final thing is, like I said, we have a important topic as well. So some tips now. So we have some tips over we have the physics asset collision used in the skeletal mesh to detect the hit, and we have the collision query params to filter the actor, and we can do a lot of the different steps with the collision param. And simple versus complex collision matters for performance and hit accuracy. What does the third point mean? So if you think like a point like, okay, if I give the complex collision for an object, it will be more accurate collision I can able to get. No, you are actually increasing the computation, and it is one of the very bad practices in the game development. So always keep your collision simple and do a lot of the mathematical stuff for balancing this one. Okay, and third thing is, you can always please use the collision responses properly. Like I said, if the bullet needs to hit only the world static object and the pawn, try to ignore all the collision responses for the other objects in the world. That will really improve the performance for the collision things and in the game performance as well. So we will see now a important thing, like we have created the collision and we have created the events as well, right? So I'm going for the edit project settings. Okay, there we can see the collision. You can see an option called object channel and preset. So before going for the preset, I'm going to tell about the object channel. So you can see you can have up to 18 custom channels including the object and trace channels. Okay, so I'm going to create a new object channel. Okay, this button here, and I'm just selecting a thing called might be a special object. So those kinds of things are special object, and what is the default response for that kind of object? It can able to block it, it will automatically block the thing. Okay, it will automatically block the thing. All right, so I have added the custom object channel. So I'm selecting the actor again, and I'm opening the blueprint. So selecting the particular box collision component, and here in the collision category, now I can able to see a new object response, a new object channel. It is called the special object. Okay, whether you can define this object type is currently world static. Now I am going to change it as the special object. Okay, and it by default, if this object is trying to hit some other object with the same object type according to the collision system, they will block each other. Okay, they will block each other. All right, they will block each other. But the third person character, right? So it is by default, you can see nothing has happened here. I'm just comparing this because sometimes things won't get refreshed. All right, so now you can see it is also blocking all the things, right? So if I need them to, like, okay, you don't need to block the special object, rather you can overlap it. Now what happens, you see overlap wins. Okay, and pawn, like it is overlapping, right? So I'm going to block the pawn. So I'm going to block the pawn. Please listen carefully here. I'm going to block the pawn, but in the BP third person character, okay, I am going to overlap the pawn. So you can able to see now the character is overlapping. Okay, So this is the important concept in the Unreal. We will use this in the upcoming videos. We will use this concept for sure in the lot of the different places, and this is one of the core concept in the gameplay programming as well. So I think I have covered the basic stuff about the collision in the Unreal. So yeah, that's all about this video. We can catch up in the next video with a lot of the different stuff. And like I said, section 2 of this video will talk about the tracing in the Unreal Engine. So we can talk about that